and welcome to the Institute for Catastrophic Loss Reduction's Hurricane Forecast webinar for 2025. Today is Monday, June 23rd, 2025. I'm your host, ICLR Chief Engineer Dr. Keith Porter. I'm speaking to you from London, Ontario, traditional lands of the Anishinaabe, Haudenosaunee, Lenape, and Ottawandaron nations. This is the second of ICLR's two annual hazard forecasts. These forecasts are in addition to our ongoing monthly Friday forum. On June 12th, we brought you Richard Carr, who gave his 2025 wildfire forecast. If you missed that, you can find the video, the speaker's slides, and a transcript at www.iclr.org/workshops. Today, we bring you Bob Robichaud of the Canadian Hurricane Center. Today, as he's done almost every year since 2010, he's going to present the 2025 annual hurricane forecast. The 2025 Atlantic hurricane season started on June 1st and ends on November 30th. Bob will tell us how active the season is expected to be and much more. Bob serves as warning preparedness meteorologist at the Canadian Hurricane Center. He's been a meteorologist for 30 years. He was briefly a weather forecaster in the private sector, but he's served in the Canadian government since 1998. Almost everyone turns to him for hurricane forecasts: insurers, Cat IQ, the media, and Environment and Climate Change Canada. So as always, we are grateful to have him with us. Before our speaker begins, here's our agenda. Our webinar will last 60 minutes. Our speaker will present for 30 or 40 minutes, then I'll moderate Q&A for the rest of the time. Please feel free to chat your questions into the Q&A box, not the chat box, but the Q&A box. I'll pose your questions in the order they appear in the Q&A box. If we have a lot of questions, I may only pose your first one, then I'll move on to others, then circle back to your additional questions. Our webinar is recorded. ICLR is going to post our speaker's slides and a link to the video in the next day or so. If you have colleagues who couldn't attend, let them know. And they can find all that material at www.iclr.org/workshops by tomorrow or so. And with that, I'll turn it over to Bob.
All right. Thank you very much, Keith. Good afternoon, everyone. Yeah, it's been 15 years that we've been doing this. So good to keep the tradition going here as we head into another hurricane season. I'm just going to close out my camera here just to save some bandwidth because there are a few graphics in here. So basically what I'm going to follow today is kind of same kind of format as I typically follow, and starting with a review of tropical cyclones, how they're different from the regular type of storms that we get here in Canada. I'll also do a recap of last year's hurricane season, look at some of the resources available for this hurricane season, and finally we'll look at how things are shaping up for this hurricane season in terms of the level of activity specifically for the Atlantic basin. So tropical cyclones. Tropical cyclone is a generic term, and it basically refers to a very specific type of storm that develops over the water that has a purpose to take the excess heat that's stored in the ocean and then transfer that to the atmosphere. So the way it does that is through the formation of these hurricanes. Tropical storms, typhoons, they're all the same type of storm, and they all have the same the same purpose is to transfer that heat from the ocean into the atmosphere. And so what happens is you get a lot of warm, moist air at the surface of the ocean that tends to rise. There's some spiraling bands around the center of the storm. If we take a cross section, this is what it looks like. So you'd have some the highest towers associated with the storm towards the center, and that center actually forms a tight ring around that area of cloud forms a tight ring around the center. A lot of the air flows up towards the top. Some of it actually flows in towards the center. Whenever you have descending air, you have warming, drying air. So that's why there's oftentimes no cloud at all, especially in the stronger hurricanes, right down to the ocean surface. So as you go out from the storm, um, the towers are not quite as high, so the winds are not quite as strong, and the rain is not quite as heavy. If you're going in towards the center of the storm, or the storm is actually approaching you, you will get these successive bouts of heavy rain and strong winds, interspersed with some calmer weather. And the eye of the storm is typically calm. Again, especially in some of the stronger storms. So this is kind of the same structure that all these storms have, whether it's a tropical storm, a hurricane, a typhoon, a cyclone. They all serve the same purpose and all have the same structure. So there's certain ingredients that are required for one of these storms to develop. One is an existing weather disturbance, and that can come in many forms. It can come in an old decaying front that drifts down from North America. Um, it could come from a disturbance off the coast of Africa, which we tend to see later in the hurricane season. Basically, any kind of disturbed weather is kind of the seed for one of these storms to develop. The other thing that we need, and the whole purpose of this storm, of having these storms, is the warm water. So we need water that's at least 26.5 degrees Celsius. But not only that, it has to be warm at a sufficient depth in order to have the amount of energy required to get a hurricane going. The other thing that we need is conditions that are conducive to thunderstorm activity. So colder um, air in the upper levels of the atmosphere, warm, moist air at the surface, which is typically what we get over the tropical oceans. The other thing that we need is an atmosphere that doesn't have a whole lot of wind shear. So basically, wind shear is a change in wind, either speed or direction, as you go up in the atmosphere. And hurricanes don't like an environment that has a lot of wind shear in it. So if there's a significant changes in either wind speed or direction, we tend to not have hurricanes developing, or they really have a hard time developing and don't really end up amounting to much. Um, Once a hurricane has actually developed, that's one of the things we look for, is for areas of wind shear. And if we do have a storm moving into an area of wind shear, it doesn't take much for that intensity to drop. So very, very sensitive to wind shear. So we want low wind shear for hurricanes to develop. And so there are different names for these things depending on the phase of development and depending on the wind speed. So we typically in the tropics, we typically get areas of thunderstorm activity that develop during the daytime and then just collapse at nighttime. So they don't stick around very long. The ones that we tend to keep a little closer eye on are the ones that last for over 24 hours. So if we do have an area of thunderstorms, um, that develop over the tropical Atlantic and they survive for 24 hours or more, we kind of keep an eye on it. When we can determine that there's a closed center of circulation, so in this case, we see the cloud pattern has more of a spiral to it. You can see here with some other larger spiraling bands that go in towards the center of the storm. We can see that there's probably a center in here somewhere. So as long as we have that disturbance that now has a center of circulation, but the winds are 62 kilometers per hour or less, that storm gets classified as a tropical depression, and that's when we give it a number. So now we have a storm that has a number, and we keep much closer eye on it than the tropical disturbance. If these storms are allowed to develop even more, and then the winds, it maintains that center of circulation, and then the winds reach that 63 kilometer per hour threshold, that's when it's given a name and it's classified as a tropical storm. And then only when the wind, that same storm reaches winds um, of 118, above 118 kilometers per hour, which is hurricane force. That's when it gets classified as a hurricane. And of course, there are five categories of hurricanes, category three, four, and five being what we call major hurricanes. And this is a major hurricane from last year. This was Milton as it was approaching Florida. So then we have the post-tropical storm. A post-tropical storm does not mean it's a weaker storm. Sometimes it can happen when you have a very strong hurricane and it becomes post-tropical. Oftentimes it will be somewhat weaker, but sometimes it can be stronger. If we're looking at a weaker hurricane and then it becomes post-tropical, it can re-intensify as a post-tropical storm, being stronger than the original tropical version of that storm. So that's something that we see here in our latitudes a little bit more. Simply what it means is a change in structure because it no longer gets its energy from the warm water. Rather, it gets its energy from differences in air temperature between north and south. Typically, that's kind of a simplified explanation of what a post-tropical storm is. So because of that, there's a change in intensity mechanism. There's a change in the structure of the storm. So we call it a post-tropical. It does not mean a lesser storm. So it's important to know a little bit about post-tropical storms because this is where it tends to happen most often. Typically, we'll get a storm going through extratropical transition, so going from tropical to post-tropical, right off our coastline about once every 2 years. So we need to know a little bit about these things um, as they come up our way. So looking at the hazards again, this is something I tend to show every year because it's always a good reminder. Typically, the strongest winds you'll experience with a post-tropical storm will be to the right of the storm. In some cases, there can be re-intensification, and you can have damaging winds on the left as well. But if you have damaging winds on the left, typically they'll be even stronger on the right. So it doesn't mean that it's not windy on the left. Sometimes it's not too bad, but when you do have wind on both sides, almost invariably it is windier on the right-hand side, which is different than the rain. The rain tends to shift to the left of the track, and um, and that's where we typically find our really heavy rainfalls that can exceed 100 millimeters, sometimes 200 millimeters. You can have some brief heavy rain on the right hand side, but again, it tends to be fairly brief in nature. Because the strongest winds are on the right, typically that's where you'll also find your um, highest storm surge and your highest waves as well. But you can also have issues on the left-hand side in certain circumstances. So this is always good to know going into hurricane season, especially when we're most likely to experience post-tropical storms as opposed to the storm when it's in the tropical phase. In terms of climatology, they tend to develop off the east coast of the U.S. Into the Gulf early in the season. Typically, about one in the month of June. Typically, 1 to 2 in July. And that area where they tend to form starts to expand eastward. With September being the peak of hurricane season, and then things start to die down a little bit, especially in the latter part of October into November. So again, this is just uh, the tracks of all the storms that have affected Canada over the years. The database for hurricanes goes back to 1851. There's some work being done to extend it back to 1842. And clearly, Canada is at risk for these storms, and we tend to get a few either uh, tracking offshore or having some sort of impact on land here on a annual basis. So that we'll kind of look back to what we experienced last hurricane season. So last hurricane season, we were looking at a number of factors that were going to influence the season. One was record warmth in the tropical Atlantic. The other was we were heading towards a La Nina, which is a cold phase in a certain part of the Pacific, which tends to reduce wind shear in the Atlantic, therefore allowing more storms to develop. So we were expecting what we call a hyperactive hurricane season, and we just met that threshold. So we had a total of 18 named storms, 11 hurricanes, and five major hurricanes, which fits in quite nicely with the predictions from last year. And there were three storms that ended up being retired, three names that ended up being retired from last year. Beryl was the first one, Helene and Milton, which we'll talk a little bit about here in a second. So those storms will be retired, not to be used again. Um, so we did, as I mentioned, achieve a hyperactive season. Although how we got there was a little bit different than what it looked like early in the season. So we started off with Alberto, and then then we had Beryl. Beryl broke all kinds of records in terms of intensity, in terms of where it formed, in terms of um, the earliness of the storm of that nature developing. So there was lots of records broken there. So we thought, here we go, we're off to a blistering start here for the 2024 hurricane season. Then we had a bit of a lull after that. We did have Debbie. Um, that actually ended up resulting in some indirect impacts here in Canada. We had Ernesto, which was the only tropical storm, tropical cyclone that entered our response zone as a tropical cyclone last year. Stayed well offshore, did not have much in the way of impacts on land. And even after Ernesto into late August or early September, even, there wasn't a whole lot happening. And then it's like someone flipped a switch, and then things started going again. And we just had storm after storm. And then, of course, that's when we had Helene and Milton as well, which were very, very damaging storms last year. So start with Beryl. Beryl was again a record-breaking hurricane. It was the first on record to become a Category 4 and 5 because it reached Category 5 status. Um, it was the third earliest Atlantic hurricane on record. It was the earliest June major hurricane that formed um, east of the Lesser Antilles. Again, typically they form closer to the southeast U.S. Around that time of year. It was the one of the earliest storms to go through what we call rapid intensification. Rapid intensification is a process where the storm intensifies extremely rapidly. And there's a definition for that. It's about 60 kilometers per hour in a 24-hour period. So we measure intensity from the wind speed. So if the wind speed increases 60 kilometers per hour in a 24-hour period, we call that rapid intensification. So this was one of the earliest storms to undergo that kind of intensification. It made landfall at a number of locations, and then it redeveloped into the Gulf before making landfall in the Houston area. And then it actually came up into the Ohio Valley and produced some heavy rain into southern Ontario and parts of southern Quebec and New England as well, into parts of New Brunswick. So that was Beryl. Then we had Debbie. This was the National Hurricane Center predictions for the track of Debbie. And you can see by the time it enters our response zone, this line here is the delineation for our response zone. So when it entered our response zone, it was already post-tropical. So now it's behaving like a typical storm, but there's a lot of moisture associated with it. So there's not necessarily a need for the hurricane center to get involved because it's not behaving like a hurricane at that point, even though there's a lot of precipitation associated with it. So we didn't message directly on this storm, but still it resulted in some heavy rainfall um, in parts of southern Quebec. In some cases, we had rainfall rates of up to 25 millimeters per hour. and produced a lot of rain in a very short period of time, with totals of up to 200 millimeters in about a 24-hour period, resulting from Debbie. So there were significant impacts, certainly from the what was left of Debbie. 55 municipalities were impacted, over 1,000 homes flooded. There were landslides and road washouts, 500,000 without power, one fatality, and it ended up in the books as the costliest disaster in Quebec history, surpassing the ice storm, which was a major event back in 1998. And these are just some pictures of some of the flooding in Canada as a result of Debbie. Then we had Helene. Helene was another very interesting storm and became the strongest hurricane to strike the Big Bend area of Florida. You'd think some of those areas would have had storms of this nature in the past, but no, this was the strongest hurricane to make landfall in that area. And so it resulted in a number of fatalities there, number of fatalities as it moved up into the southeastern United States, both from a wind and from a flooding perspective. And it ended up being the deadliest hurricane on mainland US since Katrina in 2005. Total rainfall was up to 782 millimeters. That was recorded in western North Carolina, and it caused some catastrophic flooding there. A total of 250 fatalities, 7.4 million people lost power, and $78.4 billion US in damage there. This was fairly well handled by the computer models. This was a representation of the computer model output for rainfall as uh, Helene was moving up into the southeastern United States. The National Weather Service actually issued a press release. They had all their warnings out, their typical warnings that they would have. They had all those out, but they went a step further and issued a press release speaking of catastrophic, life-threatening flooding. Um, and of course, that's exactly what happened. You can see the observed rainfall pattern fits the forecast, the model output quite nicely. And they did a great job with that forecast and getting people to get out of the way. But again, it's the kind of event that is very hard to imagine. So a lot of people actually did not take action despite all these warnings and these press releases, um, as a result of the flooding and then the subsequent landslides that we saw because of all that rain in a mountainous area, resulted in a number of landslides and all kinds of debris flowing down these valleys into the rivers, and anybody caught up with that really didn't have much of a chance, unfortunately. And these are just some pictures from the aftermath of Helene. There's actually a gentleman that survived in the Gulf as a result of as he powered through the storm, him and his dog. They were subsequently rescued. This is a swimming pool that was near the coast that ended up being filled up with sand. Just to give you an idea of the power of the storm surge associated with the storm, and the rest is mostly in North Carolina with all the flooding that they had there because of the heavy rain and the mountainous terrain. And then the last one I'll talk about here is Milton. Again, Milton was it was a late season storm, but it was very well predicted in terms of the rapid intensification, which again set records for rapid intensification. It intensified 100. I mentioned the threshold for rapid intensification is 60 kilometers per hour in a 24-hour period. This thing intensified 135 kilometers per hour in 18 hours, going from a category 1 to a category 5 with a pressure drop of 82 millimeters in 24 hours. Most people have heard the term a weather bomb. It's kind of a loose term, um, uh, denoting a storm that has a significant pressure drop. That threshold is 24 millibars in 24 hours. Again, this thing dropped 82 millibars in 24 hours. So over three times the threshold of what we would commonly refer to as a weather bomb. So very, very rapid intensification in the warm waters of the Gulf. And it was predicted to come very close to Tampa, but just make landfall south of Tampa, which is what happened, which is good for Tampa. If you're going to have a storm coming this close to Tampa, you want it to pass south of Tampa because passing north of it would have resulted in significant storm surge in the Tampa Bay area. It was the strongest storm of the year with peak winds of 287 kilometers per hour. And there was also a major tornado outbreak, more tornadoes than we typically see. It's not unusual to see tornadoes with a landfalling hurricane, but they tend to be of the weaker variety and they tend to be just scattered. We had 46 tornadoes were reported with um, with Milton making landfall. Total of 42 fatalities and $34 billion in damage. I mentioned the tornado outbreak. It actually set records for not just a tornado outbreak associated with a tropical cyclone, but any kind of tornado um, outbreak in the U.S. So it was just an amazing phenomenon to see all these tornadoes popping up as the storm was making landfall when it did there in October from last year. So one of the questions that I do get around this time of year all the time is how bad a hurricane season are we going to get? Turns out that it all depends on what your definition of bad is. So I have here on the map on the screen track maps of two hurricane seasons. The one on the right seems like it's a much busier hurricane season, which it was, compared to the hurricane season that is on the left. So the one on the left here is last year, 2024, and the one on the right is from 2 years earlier, 2 years from now, 2 years earlier from now, 2023. So there were 20 named storms in 2023, 18 in 2024, but that does not tell the whole story. We got to look a little deeper there to see how bad the season was. So although there were more storms in 2023, we only had 19 fatalities. Whereas last year, with two fewer storms, we had 438 fatalities. Damage in 2023 was 4 billion US dollars as opposed to 139 billion last year with two fewer storms. So the number of storms that we get in the Atlantic basin is not necessarily a good indicator of how bad the season is going to be. We can get a good idea of how active it's going to be, but what we can't say is which areas are going to be impacted by which storms and how strong they're going to be when they do make impact. That is something that we have to wait for the storms to develop to actually be able to predict. So all in all, last year ended up being the third costliest hurricane season on record. There were 34 cases of rapid intensification. The typical number for a season is 15. We had over double that last year. The costliest storm was Helene. The most intense one was Milton. And what was interesting last year is something that I bring up a fair bit is, are we ready for, we plan for all these storms to potentially get impacted by these storms every year, but are we ready to get impacted by two consecutive storms back to back? We almost had that in 2009 with Hurricane Bill and Danny just a few days later. But luckily, we just had a glancing blow from Bill, and Danny kind of petered out before it got to Atlantic Canada. But in this case, last year, we had two major hurricanes making landfall about 400 kilometers apart, which had all kinds of complications and from a damage assessment point of view, from a hurricane fatigue point of view, from a staffing point of view. And that's something that I bring up from time to time is, are we ready for two back-to-back storms, which you can't predict if it's going to happen at this stage of the season, but it's certainly something that could happen. So with that, we'll just do a quick review of some of the hurricane procedures, because it's good to know who does what when a storm is on the map. So, of course, there are two hurricane centers. One is the World Meteorological Organization center that is designated to produce the official hurricane track and intensity forecast, and that's the National Hurricane Center, located in Miami, and they're responsible for not only the Atlantic basin, but also the Eastern Pacific as well. So they issue hurricanes for the Eastern Pacific as well. We don't get hurricanes here on the west coast of Canada, but we do on the East Coast. So that's why we have a Canadian Hurricane Center here as well. We have a response zone, and we actually um, uh, have it on the map here showing the area where we kind of kick into gear when we do have a storm approaching our response zone. And what we would typically do from a procedural standpoint is we would start issuing specific forecasts on the storm that's expected to enter our response zone within about 72 hours prior to the storm making land or crossing that this line or entering the response zone. Um, so we monitor everything that's in the Atlantic basin, but we would only actually start messaging a storm if it's expected to enter our response zone, and that would typically happen 72 hours, roughly 72 hours prior to the storm entering that response zone. So if you're monitoring hurricane activity over the course of the season, on a day like today, where there's not a whole lot out there, most of what you would be looking at are NOAA or National Hurricane Center products, um, and things like the graphical tropical weather outlook that shows you what storms are on the map, and it shows you areas of potential development over the next 7 days. Once a storm actually develops, again, the initial information that you would get would be from the National Hurricane Center in Miami. If a storm is approaching as it's approaching the response zone, if we're in that 72-hour time frame, that is when we would start issuing our bulletins as well. And we would have all our track maps and our text products that go with that. Some of our meteorologists would actually deploy um, uh, and and um, and be embedded with our emergency management partners. We would have briefings for our emergency management partners as well. Once we get into that 36-hour, 24-hour time frame is where we would issue the watches and then the warnings. And then in a lot of cases, like I say, um, just prior to impact, we would send one of our meteorologists over to work with our emergency management partners. Most of the detailed information you would get would be from the Canadian Hurricane Center within that 48-hour time frame. So that's how you kind of transition from looking at some of the NOAA products to looking at some of the Canadian products. So you'd rely more heavily on the Canadian products the closer the storm actually gets. So one of the things that is most often misinterpreted is the cone. Even I gave a briefing just the other day, and again, someone was a little confused with what the cone actually means. The Probably the biggest misconception is that the cone indicates the area of impact, and that's not really the case at all, especially in a very big storm. In some of the smaller storms, it could coincide to be that, but in some of the larger storms, which are the storms that we get here, because post-tropical storms tend to be bigger than hurricanes. What the cone actually indicates is the area where the center of the storm is expected to track about 66% of the time. So the way that's done is by calculating the forecast position errors for every storm, for every forecast, for all of those storms, going back 5 years and coming up with the average for that particular time. So going from 12 hours to 24 hours to 36, all the way up to 5 days, which is 120 hours. So as the forecasts are getting better and these forecast errors are getting smaller, the cone is also getting smaller, because as we draw the error circles around each point going out to 120 hours, then we join the edges of the circles. That gives us our cone of uncertainty, and that's how this is constructed. And again, it's dependent on the forecast errors over the last 5 years. And this year, because the forecast was so good last year, the cone is about 5% smaller this year compared to 2024. These are all the errors that are calculated for the different positions of these tropical cyclones. So I mentioned when we start issuing bulletins on the storm, we also issue watches and warnings. The watch, for either for a tropical storm or hurricane, would be typically issued about 36 hours prior to the arrival of those tropical storm or hurricane force winds. And a warning, once we have enough confidence that it will happen, we will pull the trigger on a warning, and that's typically issued about 24 hours in advance. One thing to watch for, not just from a hurricane perspective, but from a uh, all hazards perspective, is we plan on unveiling a new tiered alerting system. It's going to be based on colors. Um, Yellow, orange, and red. So red will be reserved for the most extreme um, cases, and that will apply for not just hurricanes, but for wind, for rainfall, for snowfall, um, all that kind of stuff. So it will have more information contained in them. For example, if we have if we expect 50 millimeters of rain right now, what we have in our arsenal is to issue a rainfall warning. So for 50 millimeters of rain in the summertime, we'd issue a rainfall warning for that within a 24-hour period. If we expected 200 millimeters of rain, we would still just have the rainfall warning. So we want a mechanism to actually highlight some of the more extreme cases, which of course we're getting more of. And that's where this tiered alerting system uh, will come into play. And again, there will be more information coming up on that as we get closer to the implementation date, which is again expected to be in the fall. So something to look forward to there. So with that, I will move on to the last section, which is the outlook for the 2025 season. And some of the main factors that we look at. One first off the bat is the water temperature in the tropical Atlantic, where these things actually develop. So colder water, of course, we tend to have fewer storms. Warmer water, we have more storms. Other thing we look at, which really helps us get an indication of how much wind shear there will be in the Atlantic, in the tropical Atlantic especially, is water temperature in the eastern Pacific, the eastern equatorial Pacific. So colder water, that would indicate a La Nina and less wind shear in the Atlantic, whereas warmer water, above zero point 0.5 degrees Celsius above normal, would indicate an El Nino, and therefore more wind shear in the Atlantic, and then therefore fewer hurricanes. The other thing is how active are the weather systems going to be coming off the coast of Africa? If it's expected to be active, those provide more seeds, more of those disturbances that I talked about earlier for these storms to develop. So more opportunities for disturbances to come to um, to grow into hurricanes if there are more of them coming off the coast of Africa. Um, so looking at the first two, looking at water temperature. This is water temperature anomaly last year, both well around the globe, but the two rectangles there, the Atlantic on the right and the Pacific equatorial area on the left. So last year there was a combination of warmer water surrounding some colder water. Where this was headed was basically more towards colder water. So we were headed towards a La Nina, whereas water temperatures in the Atlantic were record value last year. If we look at today, much cooler in the Atlantic and pretty much neutral here in the Pacific. So if we look at last year, very warm. This year, not quite as warm. It's actually trending to slightly cooler than average. That's a good indication of what we might get this year. So if we look at how things are going to change, if we look at, first of all, the Pacific, these are all plots of water temperature anomaly going into the next few months. The highlighted area in yellow here is August, September, October, which is the peak of hurricane season. Most of these models keep the water temperature in this neutral range between minus zero point 0.5 and zero point 0.5, resulting in conditions remaining neutral. So basically, no big contributions from El Nino or La Nina for this hurricane season in the Atlantic. Looking at water temperatures in the Atlantic, again, you could see that it was a very small area of warmer water, and then there were some very small patches of colder water as well. Overall, still slightly above the average, but this orange line here is basically what we saw last year. So big difference in water temperature anomaly in the Atlantic this year compared to last year. If we look at the amount of energy contained in that warm water, so ocean heat content, so this also takes into account the depth of that warm water. It's very close to average right now. Over the past weekend is the last reading we have here. So um, very close to average, which would give a good indication again of where we're headed this hurricane season. And the two lines up here are from um, last year and then 2023 as well. So a lot less heat contained in the ocean this year, at this point at least, compared to last year. So again, from a water temperature and anomaly point of view in the Atlantic, we looked at the Pacific. This is the Atlantic for August, September, October. This is actually for 2025, and it is showing above average. Now, this is the probably the most aggressive model. This is our CANCIPS model, climate model for August, September, October 2025. And we can see that it is predicted to be above normal, so warmer water in the Atlantic, but some of the other models are indicating something a little more close to normal. So that's one thing we're going to be watching as we head into hurricane season or the deeper into hurricane season. So as far as the numbers go, again, there's over 20 agencies now that um, try and predict the level of activity in the Atlantic every year. NOAA and Colorado State are the ones that we probably follow the close. Colorado State, they're kind of the pioneers in this stuff. NOAA has been doing it for about 25 years now. And their numbers are pretty much very similar to each other. So NOAA is calling for 13 to 19 named storms, 6 to 10 hurricanes, and 3 to 5 major hurricanes. And Colorado State numbers are very much the same. Colorado State issued their outlook in early April. They updated theirs on June 11th and did not change their numbers at all. So, again, very interesting there that they didn't see anything to make an adjustment there. So if we compare that with 2024 and to the 30-year average from 91 to 2000, and 20. Basically, what it's saying is maybe not quite as active as last year, but um, a little more active than just an average season. So, but again, this just refers to the number of storms, doesn't say where these storms are going to go and who's going to be hit by what. So, in terms of activity, this is what the predictions are. How bad it's going to be, that remains to be seen. So how good are these forecasts? At least the NOAA verification here shows that they're actually pretty good. There's a couple of years there, 2005 and then 2020. Those were two record-setting years where they came up a little bit short. But otherwise, the lines indicate the range, and the blue dots indicate the actual number of named storms for that particular year. So it's either very close or it's right in the range that is predicted. So they are pretty good with these seasonal outlooks. What it means for Canada? Well, the best we can do is look at the long-term average, and typically we get about 35 to 40% of the storms that form in the Atlantic end up entering our Canadian Hurricane Center response zone. Um, the percentage of those on a year to year basis can vary significantly. As we saw last year, we had 18 named storms, but we really only had one that entered our response zone as a tropical cyclone. But we did have some indirect impacts from some others as well, storms that we would not necessarily um, count as entering our response zone. And this is just something that I've been following from year to year. This is an experimental landfall probability that Colorado State University started issuing a few years ago. So, looking at the four Atlantic provinces, you see the average hurricane impact probability and this year's um, hurricane impact probability. So, for pretty much all of these four Atlantic provinces, the probability of getting the impacts from a hurricane are slightly above the average, but not necessarily as high as perhaps what we would have seen last year in terms of these predictions. So finally, the names that we're going to be using this year. Again, we have 6 lists of names that we rotate through, obviously every 6 years. So the last time we used this particular list was back in 2019. There was one storm that was replaced on the list from 2019, and that was Dorian. Dorian has been replaced by Dexter. And Dorian was obviously a major hurricane, category 5 storm that made landfall in the Bahamas and essentially stalled over the Bahamas for an extended period of time, causing lots of damage and fatalities there, and then continued on its way and impacted Atlantic Canada. Basically, all the maritime provinces were severely impacted by Dorian, which of course we won't see this year with the name being replaced by Dexter. So with that, Keith, I'll pass it back to you and remind everybody that really it only takes one storm to make it a bad year if that's the storm that actually impacts you. Um, so with that, Keith, I'll pass it back to you.
Thanks, Bob. Great talk as ever. I have a lot of questions. I'm going to give you one from our attendees. Uh, Dana Foley asks, and Dana, I'm gonna interpolate, I'm gonna interpret your acronyms here. So apologies if I get any wrong. Dana asks, which tropical cyclone characteristic do you think poses the greatest threat to Canadian property insurance? Is it simply precipitation driven flooding, or is it tree fall associated with that rainfall, or maybe surge along the East Coast? What about rainfall intensity within an extra tropical cyclone close to landfall off the East Coast? Is this possible after a storm has transitioned? So, big question. The core of that is what are the the perils that come out of a storm that you think are most costly in terms of property
Yeah,
damage?
I think if we were to break it down in looking at the different hazards, One that we're watching very, very closely, of course, is storm surge. Um, Obviously, when we get these storms, if we get one of these storms that is timed with a very high tide, we can get some significant flooding along the coast. And in some areas, we have some pretty critical infrastructure along the coast, and that can have a big impact there. But I think where we're seeing a lot of the new things happening, if you will, is as it relates to rainfall. We're seeing that these storms can hold a lot more moisture and then drop that moisture farther inland, like we saw with Helene last year, causing a lot of problems over a much wider area. So, although storm surge is one of the things we watch very closely, especially with the rising sea level, uh, the amount of infrastructure that can be impacted is somewhat limited. Whereas with rainfall, there's a lot of infrastructure that can be impacted, and we're seeing more of these heavier rain um, scenarios with these tropical weather systems. So, in terms of wind, yeah, wind can definitely be a problem. But if I was to rank them, I'd probably rank rainfall as the top in terms of that question.
Makes sense. You showed a lot of resources from the U.S. federal government. You mentioned NOAA, the National Oceanic and Atmospheric Administration. You mentioned the National Hurricane Center. Maybe you said something about the National Weather Service. And you mentioned Hurricane Milton in 2024 being very well predicted. Now, in the last 5 months, the White House has scooped out and fired much of the federal government's, U.S. federal government's technical expertise. Will the Canadian Hurricane Center need new resources to compensate for potential loss of U.S. resources?
I think, like for us, we haven't lost any resources whatsoever. We can continue to maintain um, all our forecasting capabilities. Our relationship with the National Hurricane Center remains intact. We the lines of communication there are wide open. Um, a lot of the changes that they're going through right now are occurring in the kind of the research and development side and at the local weather office level. So it's difficult to say exactly what sort of impacts will come of it because we won't know necessarily what is missing for a particular storm if there is something missing. Because one of the things that we've heard is that with the staff reductions at the local weather office level, there could be fewer weather balloons that are launched. But we know that the Hurricane Center, whether it's the Hurricane Center in Miami or even us at the Canadian Hurricane Center, can make a special request to augment the upper air observation programs at some of these sites. Over the years, and that's not because of what's happening now. That's always been in place. Sometimes here in Canada, we launch a few extra balloons when a storm is coming, just so we can get more of that data. That is still a possibility now. The with the conversations that we've had with the folks at the Hurricane Center in Miami, they have not lost any staff whatsoever. They continue to run their computer models that we are able to monitor as well. So it's at this point in the season. Obviously, things can change. Um, we're not anticipating a major disruption, but again, as we all know, things can change. So there's something we'll be watching closely. But our capabilities have not changed here at all.
Awesome. Thanks for that answer. Um, so I know this is off topic a little bit, but you showed high water temperatures in the Western Pacific today. Does that say anything about the potential for atmospheric rivers hitting BC this year? Do you have any thoughts about chances of a severe atmospheric river storm this year?
Yeah, that's a more difficult one because of uh, there's no clear, not necessarily a clear trend in terms of where we're going with La Nina or El Nino. So it's kind of in between, as you saw the from the plumes of those different models indicating water temperature anomaly. So you'd want to be able to really say that that's going to have a big difference one way or the other. You'd want a clear trend towards either warmer or colder as to whether we get more or fewer atmospheric river events.
Okay. Thanks. Dana Foley has a follow-up question. First, thanks for the answer to your earlier question. Um, Rapid intensification prevalence is increasing in research on tropical cyclones, and there are some findings that relate directly to risk in the U.S. in particular. But would this be the same for the Canadian East Coast or the U.S. Northeast? This is regarding preparedness and ability to respond, given that the storms have often transitioned and therefore not tropical. Is a transition storm able to undergo rapid intensification?
Yes, but not in the quite in the same way that we can see some of those cases of rapid intensification as tropical cyclones. When we're dealing with a pure hurricane, it's really the warmth of the water and the level of wind shear, the low wind shear in this case, uh, that allows a storm to really intensify rapidly. For us here in the northern latitudes, what we would typically see is a storm like Fiona, for example, that intensified rapidly once it crossed the Caribbean and started to make its way for here towards eastern Canada. It did go through some of that rapid intensification. So you're starting with an overall storm that's much stronger before it starts making that transition. You can see some reasonably rapid intensification as a storm, but typically that has an upper limit compared to what you would see with a purely tropical storm. Now you can see some fairly good rapid intensification in winter storms, but when we're dealing with a post-tropical storm, you typically don't have enough of that really, really cold air on the cold side to really spin it up as much as you would say a winter storm.
We only have time for perhaps one more question, and I have one. You mentioned the possibility of back-to-back storms. And as I understand it, back-to-back storms uh, aggravate the potential for severe flooding because they saturate the soil. So what rainfall does fall out of the sky in the second storm can't soak into the soil. It's got to uh, run overland. Um, has Do we have a projection of the effect of climate change and the long-term trend in the number of named storms per year? And if so, how long until we can begin to expect back-to-back storms as the new normal?
Yeah, if we look at and it's counterintuitive a little bit when it comes to the number of storms. If we the modeling that has been done shows that we would typically get a little fewer storms
Hmm.
than if the climate wasn't warming. But the storms that we do get would be of the slightly higher end variety in terms of intensity. So, and the models are pretty consistent in painting that scenario of slightly lower number of storms, but more the storms we do get, the intensity would be a little bit on the higher side. So that's the counterintuitiveness of it from a number of storm perspective. So it's difficult to say from if we are at higher risk of getting back-to-back storms, given that we might have fewer number of storms. In terms of the intensity, uh, yeah, that would mean that a storm has less of an option or less of an opportunity to weaken before it arrives here. So that potential is there. There's no question about it.
Awesome. Cool. Well, thanks again, Bob. And thanks everyone for attending today. Remember, if you have colleagues who couldn't attend, tell them to check out the video, the slide deck, and the transcript at www.iclr.org/workshops. Join us for our next Friday forum on Friday, July 11th from 1 to 2:30 p.m. Eastern Daylight Time, when our own Dan Sandink and Tamara Mosqueda will tell us about the market value for home resilience. They'll tell us about that and other aspects of ICLR's collaborations with home builders. Thanks, everyone. Thanks very much, Bob. And I hope to see you next time.
Sounds good.
Bye.
Thank you.
Thank you.